Today we're going to continue talking about factoring, and this specific day is talking about factoring the greatest common factor. So when we look at problems like this, we see it says factor the following expression, and it's a little bit different than what we've seen in that it doesn't have a trinomial, there's no constant term, we have two terms with a variety of variables, a variety of exponents. And so to be able to do this, we need to be able to factor using the greatest common factor. The problem is many of us don't exactly remember what is the greatest common factor, commonly referred to as the GCF. So the greatest common factor it is called the GCF because we have the G, the C, and the F in the leading letters of each of the words. And it is the greatest factor common to all terms, which means divide evenly. Okay, this value is very, very specific. Okay, a common factor, on the other hand, is any factor of all the terms. And there can be many of these. Okay, so we look back at our example and we notice it says 32c squared xy minus 4d squared xy. And we're definitely going to need our workspace. And the reason why we need the workspace is because we need to break everything down by its prime factors. So if I look at the 32c squared xy, its prime factors would be 2 times 2 times 2 times 2 times 2, c times c, x, and y. If I break the 2d squared xy down, I'll notice that I have 2. Sorry, I changed the problem. 4d squared would be 2 times 2. D times d, x, and y. So as I'm looking at this, I notice that I have a 2 here, paired up with a 2 there. A 2 here, paired up with a 2 there. There are no more 2's coming from the 4d squared xy. I notice an x, and I notice a y pair. And so my greatest common factor will equal 2 times 2x times y, which is 4xy. Then I look at the remaining factors. And I see in the first number there is a 2 times a 2 times a 2. I also see a c times a c. That in total equals 8c squared. There are no more numbers left here, but I see a d times a d, and so this is going to become d squared. Where this is helpful is you can rewrite this expression as 4x times y from the GCF and then the remaining values for the terms. So 8c squared minus d squared. Of course, you always check your work. And so I would have 4xy times 8c squared minus 4xy times d squared using our distributive property, which gives me 32 c squared xy. We generally list things in alphabetical order. 4d squared xy. So it checks out. So that is us factoring with greatest common factor. I also mentioned that you had common factors. So a common factor would be any one of these letters or numbers being factored out of the expression. For instance, I could have just factored out a 2. So here's a common factor. I could have just factored out a 2, and then I would get 16c squared xy minus 2d squared xy. That's just one of many that you can choose from. I could have chosen to factor out just the x and the y. And then I would have 32c squared minus 4d squared. What I want to do is pose a question to you guys before we continue. What is the difference between a common factor and a greatest common factor? So what is the difference between a common factor and a greatest common factor? I want you to pause the video, reflect on that. Okay. Welcome back. Our next problem has a lot going on within it. But again, we're going to have all of our side work trying to figure out the greatest common factor. I noticed that the first term is 3y to the 4th. The next term is 81y to the 7th. If I break this down, that's 3y times y times y times y, where 81 is 3 times 3 times 3 times 3, y times y times y times y times y times y times y. If I go back through this, I'll notice that I have one pair of 3's matching up. 1, 2, 3, 4 pairs of y's matched up. Therefore, my GCF is simply going to be 3y to the 4th. So I have 3y to the 4th on the outside of the parentheses. What I notice is there's nothing left here, which means there is one remaining factor, which is a 1. So I would highlight this. This is really important. It's probably the most common misconception, is that when you have everything circled, a lot of students want to put a 0, but there isn't. There's always a 1. So it's 1 minus 3 times 3 times 3 is 27. Y cubed and what I'd like you guys to remember in STAR is that we must maintain the same number of terms. So I started with 2 terms, and I must end with 2 terms. But I also noticed that I can keep going. So 3y to the 4th times 1 minus 27y to the 3rd actually has the form of difference of cubes. And I know my difference of cubes is a cubed minus b cubed, which is equal to a minus b quantity times a squared plus ab plus b squared. I would write this down if I didn't have it memorized. It's a useful equation, and therefore I can rewrite this as 3y to the 4th power times the quantity 1 minus 3y times the quantity 1 plus 3y plus 9y squared. Final answer. Our last problem has a mixture of exponents, but only one variable, and coefficients. So it's the first trinomial that we've worked with, but still we need our space for our work, GCF. I have 6x to the 5th, I have 8x to the 4th, I have 14x to the 3rd. So I notice I have a 2 times 3, x times x times x times x times x. 8 is going to be 2 times 2 times 2 with 4 x's. And this is 2 times 7 with 3 x's. Now again, one of the most common misconceptions is because we call this the greatest common factor, we see 5 x's here. And it doesn't mean greatest number of x's, it means the greatest number in common. And so if you look very carefully, in common, they only have 3 x's. Okay? So we get this circle around the 2's, we get the circle around the 3's, so my GCF is going to equal 2x cubed. What's left over comes out in this trinomial, so it's 2x cubed times the quantity 3x squared minus 4x minus 7. But we're not done. And so this brings us back full circle to what we did the other day, where I have to multiply the 3 and the negative 7, you get negative 21. So the products of numbers that add, multiply to negative 21 but add up to negative 4. So product, sum. Well, what things multiply to 21? 1 and 21. Negative 3 and 7. Negative 7 and 3. And negative 21 and 1. Well, negative 7 plus 3 is negative 4, so this is the pair of numbers that I'm working with. Now what's nice about 3 is a prime number, so I know automatically that I have to split it up into 3x times x. I want a factor of a negative 7, and I need a factor of positive 3, so that's 3 times 1. That gives me the 3x that I need. This gives me the negative 7x that I need. And negative 7 times 1 is negative 7. So my final answer, 2x cubed, 3x minus 7 times quantity x plus 1. So these are examples of not only GCF, but continuing the factoring until it's completely done. Pause, take notes, remember vocabulary, it's such as trinomial, binomial, terms, factor, greatest common factor, difference of cubes, difference of squares, and give yourself a little summary at the end of this. Thank you.